Hello, this is Mr. Stansbury. I'm going to take you through the 2022 Time Zone 1, Paper 1 for the A&I test. Okay, so let's get right to it. Here's our first problem here. Front view of a doghouse is made up of a square with an isosceles triangle on top. Doghouse is 1.35 meters high, 0.9 meters high, sits on a square base. So this whole square piece right here tells me that this height here is also going to have to be 0.9, which then would make this triangle right here. Would have to, if this is 0.9 and this is 1.35, we take 1.35 minus 0.9 and we get 0.45. That's a 5 for the height here. I'm going to redraw it over here so it looks a little nicer. It gets bigger so we can see it a little better. Pretend that that's isosceles. You get the idea. So that is 0.45. This whole length right here is 9, 0.9. So that means each one of these, cut that in half, and we get 0.45. So, because what we want to do is we want to figure out what this length is here, so we can multiply it by this length here, which we know is 0.9 as well. And then we'll double that, and that should be the surface of both of the rectangular roofs of the doghouse, right? So let's do a squared plus b squared equals c squared. So that's going to be 0.45 squared plus 0.45 squared equals c squared. So let's see what we get for that. 0.45 squared plus 0.45 squared gives us 0.405. So we get 0.405 equals c squared. So we'd want to square root both sides and get that c. Square root this. Second answer, I would definitely use a lot of second answer on this when you're doing your test so that it doesn't round until the very end, which is what you really want to do. So we get 0.636. 0.636 is going to be this, not 7, but 6. It's going to be this length right here. So that's this length right here. Let's put it over here, 0.636. So to find the area of each one of these is 0.636 times 0.9. So our best bet, here, let's do this, 0.636 times 0.9. It's going to be each one of our triangles. We already have this unrounded number in here, so I would definitely multiply that by 0.9 instead of retyping in 0.636 because this again is unrounded. We get 0.573 rounded off. Let's put it over here. 0.573. That's for each one of the two, so we'd have to take 0.573 and multiply it by 2. And again, we already have the non-rounded answer in here, so I'm just going to multiply that by 2, and we get 1.15 if we round it off to 3 significant figures, right? So we get 1.15, and again, we're going to want to put our label on there for sure. This is meters, so that's going to be meters squared is going to be our final answer for how much of the surface of the roof doghouse. Sorry, how much? Find the area to be painted. So that's both of the two tops. They're not including these little triangles here on the side. Okay, moving on to number 2. A vertical pole stands on horizontal ground. Bottom of the pole is taken as the origin O, which means it's going to have coordinates. Whoops, that didn't work. 0, 0, 0. A coordinate system which in the top F is 005.8, and then this point down here is 3.2, 4.5, and 0. Pole is held in place by ropes attached at F. One of the ropes is attached to the ground at point A with these coordinates that we just talked about. The rope forms a straight line from A to F. Find the length of the rope connecting A to F. So we've got, this is like where our 3D distance formula is going to come in handy, which is distance equals the square root of I believe it's usually x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. And it doesn't matter if it's x2 minus x1 or x1 minus x2 because you're going to end up squaring it, so the sign is going to not matter anyway. So if we do plug everything in here, we've got, like, let's call this x, we'll call this 0.1. Let's see, we'll call this, 1, and we'll call this 0.2. So we would do x2, so we'll do 3.2 minus 0 squared plus 4.5 minus 0 squared plus 0 minus 5.8 squared. Okay? And then we'll square root all that. So good news here is this, since we're just subtracting 0 and we're doing 0 minus each time, all these are just going to be the numbers that they're in there. So we got 3.2 squared plus 4.5 squared, and then it's really negative 5.8 squared, but again, the negative is going to go away with the square, so I'm just going to put plus 5.8 squared. Okay, so then we put that in our calculator, which I have already done here. So just to maybe help you out, I did second, here we'll just do it again, second square root. And I did the parentheses in there because I was going to include each piece, but I don't think we even really need to worry about that. So we'll just do 3.2 squared plus 4.5 squared plus 5.8 squared. Enter, and we get 8.008. So if we round that to three significant figures, we're 8.001. So the distance for A here, distance is going to equal 8.01, and this is, all units are in meters, so I'm going to do 8.01 meters. Okay, circle my answer so they know that, so they're going to be looking for that one there. Find angle FAO, the angle the rope makes with the ground. So F to A to O, A is always the vertex, so we're looking for this angle right here, right? So if we are looking for that, we know that this length here, we already know, we just figured that out, is 8.01. And then this height here is, this point up here is 005.8. So that means it's directly up 5.8. So I would definitely put 5.8 for this one. And now we have the opposite side, and we have the hypotenuse. So if we're looking for that angle there, we're simply going to do opposite and hypotenuse. You'll have to remember SOHCAHTOA, because that is not on your formula sheet, right? So if we look at this, opposite and hypotenuse is sine. So we would want to do sine of theta equals opposite, which is 5.8 over 8.01. So again, we already have that 8.01 in there, so let's try this. We'll do second sine, because it's always the inverse sine whenever we're looking for an angle, right? So we'll do second sine of 5.8 divided by, and I'll do second answer, and we get 46.4 rounded to three significant figures. So we get theta equals 46.4 degrees. So in fact, I would not even circle that because it says FAO. So just to make sure, I would do this. FAO equals 46.4 degrees. I would circle that as my answer. This would probably be okay, but just to make sure, this is officially more accurate. It's more correct because it's not theta. They didn't ask for theta. They asked for FAO. Okay? Okay, moving on to number 3. Height of a baseball after it's hit by a bat is modeled by the function, blah, 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 where h is the height in meters above the ground and t is the time in seconds after the ball was hit. Write down the height of the ball above the ground at the instant it is hit by the bat. So if we're looking for that, the instant that it's hit by the bat, time is 0, right? So h at 0. You don't have to put the 0 in there. That's just saying the height at 0 is going to be negative 4.8 times 0 squared plus 21 times 0 plus 1.2. That's going to turn into 0. That's going to turn into 0. So that means the height at 0 is going to be 1.2 meters. So height is going to equal 1.2 meters. Okay? That's part A. Part B says find the value of t when the ball hits the ground. Okay, so that's when h is going to be back at 0, right? Let's start doing these in a different color to make this a little easier to see what we're doing on each part. So that means now this right here is going to be 0. So we do 0 equals negative 4.8 t squared plus 21t plus 1.2. Now, several ways you can do this. You can try to factor it. Not going to be nice. You can plug it into the quadratic. It's going to take a little bit of time, and you might make an error. Definitely your best bet on this is to go into Apps and go to Polysymult 2. So in this case, it's number 9. And we're going to do Polynomial Root Finder. This Polynomial Root Finder is the quadratic formula, and it's just going to solve it for you. And then the only other one you'd ever use on this would be Simultaneous Equation Solver. That's the only 2 programs really there are. That's if you have 2 equations with 2 unknowns or 3 equations with 3 unknowns. But anyway, we want to do Polynomial Root Finder, so we're going to push Enter. And then it says Polynomial Root Finder Mode Order. That is going to be the highest power that we have in here. So the order on this one would be 2. And then we want real answers. It says auto or decimal. Let's just leave it as a decimal, normal, float. All the rest of this stuff should be fine. And then now what we're going to need to do is we need to push this next button. And this is where some people get confused. This next button, if you look here, it's got this little box around it. So that means you're going to hit the graph button. And that means next. Now we're simply going to enter in, as long as we got one side equal to 0, see how this side's equal to 0, we're going to want to enter in these numbers into this spot here. So the first one's negative 4.8. Remember, if you want negative 4.8 instead of subtract 4.8, we have to push negative and then 4.8 and then enter, and it won't put that in there. And then this is plus, which is what it's supposed to be. So we just push enter. If it was negative or we wanted to change it to negative, you just type that in. Next number we want is 21. Push enter. And then the next one is plus. That's already there. And then we've got 1.2. And we push enter so that it puts that in there. When we're all done, we now want to push the solve button, which is going to be, again, the graph button. We push that, and it gives us 2 answers, negative 0.056 and 4.43. You don't have to do this part, but just so you understand what this is talking about, is if we're going to graph this thing, which, again, they're not asking you to. Here's our graph like so. This is what we're looking for. We're looking for that intersection here. And what this is doing is this is giving us also this negative time answer over here. That's what the negative 0.056 is about. So we want the other one. 4.43 is going to be how long it's going to take. So find the value of t when the ball hits the ground. T equals 4.43, and this says time in seconds. 4.43 seconds is how long it takes to hit the ground. And then part C, last part here, state an appropriate domain for t in this model. So it's like, what can t be, right? So it doesn't make any sense for t to be negative, because that would be negative time, which wouldn't make sense. So that means we would start with 0, and then we'd want to go less than or equal to t, and then t is going to go all the way up to 4.43 seconds. After that, it's now gone into the ground, which also doesn't make sense. So then we would want t to be less than or equal to 4.43, and we could maybe even put s for seconds in here, and that would be our good a good domain there. Okay, officially on the answer sheet it doesn't have the seconds in there, so you do not have to put that on there, but I can't imagine that they would mark that wrong if we had that. Okay, on to number 4. All right, number 4, 3 towns A, B, and C are represented as coordinates on the map, where x and y axes represent the distances east and north of an origin, respectively measured in kilometers. There we go. Town A is located at -6, -1. B is at 8, 6, and the road runs along the perpendicular bisector of AB. This information is shown in the following diagram. Find the equation of the line that the road follows. So we're going to come up with the equation of this line here. So that's basically the perpendicular bisector of these 2 points. So to find the perpendicular bisector, we got to do 3 things. We've got to find the midpoint. And then we have to, from the midpoint, we got to find the slope. And then once we find the slope, we got to find the perpendicular slope. And then we're going to use our midpoint and our perpendicular slope and plug it into y minus y1 equals m times x minus x1. Right? That's an x minus x1. Okay, this is the point slope formula. This is another thing that is not going to be on your formula sheet. You're going to have to memorize that one. If you want to use that. You can also, it does have point slope on there, but I don't believe it has this on there. I don't have the formula sheet in front of me, but I'm pretty sure it doesn't. Anyway, so these are the 3 things we got to do, 4 things if you want to say slope and perpendicular slope are 2 different things. Anyway, find the equation of the line. So we're going to do the, find the midpoint first. So that's going to be 8 plus -6 over 2. And 6 plus -1 over 2. It doesn't matter which point you start with, as long as you just always want to have, it's good practice to always use the same point. If you start with this B point, start with it on both. It won't really matter in this one, but it will matter on slope. So 8 plus -6 is 2 over 2, and 6 plus -1 is 5 over 2. So let's simplify that to 1 and 2.5. You can leave it as 5/2 if you want, or 2.5. I just prefer decimals, so there's our midpoint. So we got that. We want to find the slope between these two. The slope formula is in your formula sheet, and it's usually y2 minus y1 over x2 minus x1. So let's do that. So slope is going to be 6 minus -1 over 8 minus -6. Right, so that's going to give us 6 plus 1 over 8 plus 6, so that's going to be 7 over 14, which just gives us that the slope here is 1/2. So that means the perpendicular slope, we have to flip it over and switch the sign, right? So that flip that over, it turns into 2 over 1, and we got to switch the sign, so it's going to be -2 over 1 or simply -2. So these are our 2 pieces that we're going to want to plug into the point slope formula. Point slope formula again is y minus, this is our y1 and this is our x1, right? So y minus 2.5 equals our slope, which is -2, times x minus x1, which is 1, and then we just want to simplify this thing here. And really, with IB, they don't actually make you simplify it. So you can just leave it like this if you want to, or you can simplify it. If you look at part B, it says find the y coordinate of town C. We have to plug stuff in for x anyway. I know we're gonna have to move that over eventually, so I'm just gonna move this. I'm gonna simplify this here. So we got y minus 2.5 equals -2 times x is -2x. -2 times -1 is +2. Add 2.5 to both sides, and we get y equals -2x. 2 and 2.5 is 4.5. So there's our other formula. Again, this is actually the first answer that the answer key has in there. You can do this one or this one. You can also put it into standard form, which I would not suggest doing at all. This is probably going to be your best bet, because then you will not, there's no math to do to mess that up. So I would leave that as a circle, but I'm going to use this for when we do part B. Again, you can plug in x into this and just simplify. You know what, let's just do that, because really that probably should be, this should be the way that we go about it. So let's do that. Y minus 2.5, because sorry, it says find the y coordinate of town C. I got a little ahead of myself here. So But it does say town C is due north of town A, which means that this has got to have the same x value, which is -6, and we're looking for that y value right there. So we can use this formula, y minus 2.5 equals -2 times, we know that the x has to be -6, and then minus 1. So we got y minus 2.5 equals -6 and -1 together is -7. So that's -2 times -7. So y minus 2.5 equals +14. Add 2.5 to both sides. And we get that the y coordinate is going to be 16.5. Okay? Okay. Okay, number 5. Ticket prices for a concert are shown in the following table. Total of 600 tickets were sold. Total amount of money from ticket sales was $78.16, and there were twice as many adult tickets sold as child tickets. Let the number of adult tickets sold be X. So this is going to be X. The number of child tickets are going to be Y, and then the number of student tickets are going to be Z. Okay? Write down 3 equations that express the information given above. Good news is, look at that. They give us 1, 2, 3 different pieces here, so that should be our 3 different equations. It says a total of 600 tickets were sold. So if we add all the X tickets plus all the Y tickets plus all the Z tickets, it should equal 600. So we should simply just do X plus Y plus Z equals 600. That's one of our formulas. Second one, the total amount of money from ticket sales was $78.16. So for every adult ticket, we get 15. Every child ticket, we get $10. Every student ticket, we get $12. So we would simply want to multiply the X by 15. So that's going to be 15X plus 10 times Y is 10Y plus 12 times Z is 12Z equals 78.16. Okay? And then the last one, there were twice as many adult tickets sold as child tickets. Okay? This is the one that can get a little tricky. So, twice as many adult tickets sold as child tickets. So what I'd like to do is just say, okay, let's say if I sold 10 child tickets, how many adult tickets would I have sold? So there are twice as many adult tickets sold as child tickets, so that means we would sell 20. So for every child ticket, we would have to double the child ticket to come up with the adult ticket. So that would mean we would want to say 2 times the child is Y. So 2Y should equal X. So you got to take the number of children's tickets, multiply it by 2 to come up with the number of adult tickets. Okay? All right. All right. Part B says find the number of each type of ticket sold. So we've got these 3 equations and we have 3 unknowns. So we are definitely going to want to use our polysymult 2. We'll pull the calculator up here. But what we want to do first is we want to have all the X's first, then all the Y's, then all the Z's, and then the numbers. Okay, so right now the first line and second line are great. We just want to move this over. So let's do this. Let's subtract X from both sides. So we get negative X plus 2Y. I'm going to put plus 0Z equals 0 over here. So now we have 3 that all have X, Y, and Z values. Okay, so now what we're going to want to do is back into this. We're going to want to go, let's just do this second. Let's see, quit app is number 6, just so that we can go back into it fresh. So we go back into apps and we're going to do polysymult 2. Okay. Oh, I did not push the right number. Let's see if we can get out of here. Second quit worked. Okay, apps. Sorry, polysymult 2 is number 9. I don't know why I pushed 2. So, polynomial root finder is the quadratic formula simultaneous equation solver. You want to make your life easy, use this. You get the calculator for this test, use this. Otherwise, you're going to burn a lot of time going through and solving this all by hand. So, this is what we want. So, we push enter, and then now it's number of equations and number of knowns. These should match in here. And it's either going to be 2s or 3s. I haven't seen 4s or 5s or anything like that there before. So we have 1, 2, 3 equations and 1, 2, 3 unknowns. So we want to do 3 for both of those. So move that over to 3. Go down here. Move that over to 3. Push enter. All the rest of this should be fine. And then we're going to hit the next button, which is the graph button. See how it's in this little bubble here. So we put next, and then we're going to put in all of our numbers here. So this is 1x, 1y, 1z, and that's negative 1x, 2y, and 0z. So we have everything in there. So now it's just a matter of putting those all in there. So 1, enter. It's going to take a little bit. I'm just going to pause this while I put this all in because you don't need to listen to me while I do this. Okay, so I finally got everything all in there. Notice that these are all pluses except for this negative 1 out here. Good news is I actually went through and I kind of messed this up and I kept putting 10 in here when I was supposed to be putting the plus in there. So good news is it wouldn't put 10 in there. It would just left it as a plus. So anyway, once we get everything all in there, we're going to hit the solve button here. And it should tell us exactly what we need to know. X is 308. So that means that we sold 308 adult tickets. We sold 154 child tickets. And we sold 138 student tickets. Now, I'm just writing it like this so that I don't have to go back and forth on the calculator. I definitely want to write my answer correctly. Find the number of each type of ticket sold. The answer key has X, Y, and Z, but it also says accept answers written in words like 308 adult tickets, 154 child tickets. So that makes more sense to me, but I'm just going to write it their easy way. So we'd say X equals 308, Y equals 154, and Z equals 138. And again, circle it, box it, make sure it's very easy for the grader to find your answers. Okay? All right, on to number 6. Okay, number 6. A modern art painting is contained in a square frame. The painting is a shaded region bounded by a smooth curve and a horizontal line. So, smooth curve, horizontal line, this is the painting. When the painting is placed on a coordinate axis such that the bottom left corner of the painting has coordinates 1, -1, and the top right corner has coordinates 2, 2, the curve can be modeled by y equals f of x, and the horizontal line can be modeled by the x-axis. Distances are measured in meters. Use the trapezoidal rule with the values given in the following table to approximate the area of the shaded region. Now, I got to say on this one here, this is in, I believe, chapter 13, which we did not do. But I'm showing you this anyway because really the trapezoidal rule is not too difficult. And like whenever this chapter 13 stuff shows up, it's almost always the trapezoidal rule. This shows up about every other year, so this could be the year that we see this one again. So let's go over this. I'm going to show you this rather briefly, and I think it should make a fair amount of sense to you. So here's what I like to look at. This is -1 here for the x all the way up to 2, so that means this is a distance of 3, and this is -1 down here up to 2 there, so this is also a distance of 3. So I'm just going to kind of break this into 3 different little sections here, and then we've got like say 1, 2, 3 that way. That doesn't matter as much, but what we want to do, the trapezoidal rule is we're going to break this section here into several trapezoids, find the area of all the trapezoids, and we're going to add them all together. So here's what we want to do right here. This is kind of the handy part here. It's this table here says that when x is -1, which is -1 right there, there's 0, there's 1, and there's 2. When x is -1, it says that y, this y distance right here is 0.6. So this is 0.6 right here. And then it says when x is 0, this distance right here, that distance is 1.2. And then when x is 1, this distance here is also 1.2. And then it says when it's at 2, the distance there is 0, which is pretty apparent. Okay, so now what we're going to do is we're just going to make these trapezoids here. Now, I can't remember if the trapezoid formula is in your booklet, but area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So you're basically taking the average of the two parallel pieces and multiplying it by the height. So these are the two parallel pieces, and that's the height. So there's going to be 1, 2, 3 trapezoids that we're going to estimate here. So what we want to do here is this first trapezoid, area of the base is going to be, the two bases are going to be 0.6 and 1.2. So we're going to say area equals 0.6 plus 1.2 divided by 2 times the height. This distance right here is from -1 to 0, which is 1. So this has got a distance of 1, this has got a distance of 1, and this has got a distance of 1. So times 1 plus, now we're going to find the area of this other trapezoid. So that's 1.2 and 1.2. So 1.2 plus 1.2 divided by 2 times the height, which is 1. And then we're going to add the last one in here. The length of this base is 1.2 and that base is 0. So we do 1.2 plus 0 over 2 times 1. And now we simply simplify this out. So that's going to be 1.8 over 2, right? And then 1.2 plus 1.2, times 1 is still just 1.8. This times 1 really makes it easy because a lot of times this is going to be like a half or a quarter or something different like that. But they made it nice for us on this one. So be cautious of this depending on how long this is and how many pieces they split it up into. You got to be careful of this length here. It just happens to be 1 to make our life easy. 1.2 plus 1.2 is 2.4 divided by 2 times 1 is just going to be this. So I'm just going to leave the times 1s off. And then 1.2 plus 0 is 1.2 over 2 times 1. So 1.8 divided by 2 is 0.9. 2.4 divided by 2 is 1.2. And 1.2 divided by 2 is 0.6. So the area of this here, adding these all up, that's what? 2.1 plus 6 is 2.7. And does it say what these are all measured in meters? So it's going to be area is 2.7 square meters is going to be our estimate for A. All right? Okay, now for part B, it says find the exact area of the shaded region in the painting. That's where we have to do this. We have to use this summation notation business, which we again did not do. But the good news is it is in our calculator. So we want to quit the app here. What we're going to do is we're going to simply go into y equals, and we're going to enter in this equation here. Now, we got this whole thing on the top divided by this on the bottom. I'm going to suggest doing on your calculator alpha y equals, which will give us these fraction options. Just use the first one here, and I'm going to enter this whole thing in here, right? So we got negative x to the third, go over, so we get out of the power there, minus 3x squared. Okay, and then plus 4x plus 12. Plus 4x plus 12 on the top, and then on the bottom we just have 10. So there's our graph. So there's our equation. Now we hit graph, and as long as hopefully your graph will look like this. If it doesn't, and it's going here, it's going to take a second. You're going to want to hit zoom standard, and it will automatically default to this, to doing a 10 by 10 here. Okay, so it's taking its own sweet time here to graph. But there it goes. This is the equation of this graph. And if you'll notice, look, here's negative 1, 0, 1, and 2. So it's actually this section right in here. And our calculator will actually calculate this for us. So here's what we want to do. Remember, pretty much 90% of the time, whenever you're in a graph and you want to figure something out from it, you're going to do second trace, probably 99% of the time. And we're going to use something that we have not used, but we would have used had we done chapter 14. And we're going to want to choose this here. It's the summation formula down here. Okay, so we're going to head down to number 7. Okay, and then it's going to say lower limit. Our lower limit is -1, and our upper limit is going to be +2. So on this here, lower limit, and we're going to do, you simply just enter in -1, and then it says upper limit, and then we will put 2, and then you push enter, and voila, it's going to actually go through and it's going to shade in all this piece here, which is basically, this is going to be a really small version of this, but it's the exact same thing here. And it's going to, when it's done shading, it's going to actually tell us the exact area of this shaded region here, which is 2.925. So for part B, we're going to get 2.925, just double checking. I really should be labeling these as we go along. Like this up here, I should have put A on here for my work so they know exactly what's going on. Don't make the grader hunt for your stuff. So anyway, so this is our 2.925 square meters is going to be the exact area of the shaded region in the painting. Okay? And then part C says find the area of the unshaded region in the painting. Now this whole thing here is a square. It's 3 by 3. So we would simply just go 3 times 3 is 9 square meters. And we're simply going to subtract off the shaded area. So we're going to do 9 minus 2.925. And that's going to give us the area of the unshaded region. So second quit. And we're going to just do 9 minus 2.925, I believe is what we had, right? 2.925, 2.925, 2.925. Just triple checking to make sure we have it. Push enter, and we get 6.075. And that is square meters. Now, oh, let's see. I did 2.925. Did it say... It says find the exact area of the shaded region. So I didn't round it off, because if this was 2.925 and the decimal kept going on and on, then I would have rounded it. But we want to find the exact area, so we're going to leave it just like that. And so that means that the area of the unshaded region is going to be 6.075 square meters. Okay? Okay. Now, it does say on the answer here, it's interesting. It does say the answer is 6.08, but it does have 6.075 in parentheses, which I think means that we will get credit for this. Since this said exact area, that's why we left it like this. This says find the area. It doesn't say anything about exact area, so that's probably why they're rounding it off. So 6.08 square meters might be our better answer instead of 6.075. Okay? Okay. Moving on to number 7. All right, number 7 here. Leo is investigating whether a 6-sided die is fair. He rolls the die 60 times and records the observed frequencies in the following table. So here's what we've got. Leo carries out a chi-squared goodness of fit test at a 5% significance level. Part A, write down the null and alternative hypothesis. Okay. Now, when we did this in class, we had all of our probabilities written out. But in looking at our lovely answer sheet, basically, our null hypothesis is always that, hey, everything's fine. Don't worry about it. So our for part A, we would do HO. They have the die is fair. And then that would mean that H1, the alternate hypothesis, is that the die is not fair. Okay. Again, in class, what we would have done is we would have had that probability of, we would have done this, like probability of 1 equals 1/6, probability of 2 equals 1/6, so forth and so on, all the way up to probability of 6 equals 1/6. Right, and then this is the HO, and then the H1 would have been at least one of these is not true. So we would do at least P1 does not equal 1/6, or P2 does not equal 1/6, so forth and so on. But again, the answer key is giving us credit for this. So let's take we'll take the kind of the easier route on this and just say the die is fair or the die is not fair. Okay. Part B says write down the degrees of freedom. So degrees of freedom, and it says write down means there's no work to be shown on this. But I always find the easiest way to do degrees of freedom is, and I'm not going to try to do it too dark here, I'll do it kind of light, is I'm going to cross off a row and cross off a column and then count however many cells I have left. 1, 2, 3, 4, 5. So our degrees of freedom equal 5. Okay? Part C says write down the expected frequency of rolling a 1. Okay, so the expected frequency. So if you roll 60 times, we know that the probability of rolling a 1 is 1/6. So if we're going to do part C, if we roll 60 times, probability of rolling a 1 is 1/6. We do 60 times 1/6 equals 10. So we would expect to get 10. Expected frequency of rolling 1, we'd expect to get 10 ones if we rolled it 60 times, just like it says in this here. Okay, I forgot to circle my answer back up here, so I'm going to go back and do that. Okay, part D, find the p-value for the test. Okay, so I'm going to find a different color here. I go to a different green. So let's see, find the p-value for the test. This is where we got to enter it into our calculator, right? So if you'll remember, whenever we're putting all of our stuff in, the only time we ever need to use the matrix is if it's the chi-squared, not goodness of fit, but just the plain old chi-squared test for independence. So since this is chi-squared goodness of fit, we're going to go into our stat and edit. And we're going to put in all of these for list 1 and all of those for list 2. I'm going to pause that so you don't have to watch. Oh, by the way, if you do want to clear out all the data that's in there before, you highlight it and push clear. And go, once you go down, back down into it, it will disappear. But right when you hit clear, nothing happens until you push the arrow down, and then it will clear. Okay, I'm going to pause and put the data in here. Okay, scratch what I just said because I just realized I did that incorrectly. Here was my big hint because I put the data in there and I went over to stat. Let's see, because I told you how to put this data in, but it's a little bit different. So we go over to tests, and we're going to do the, come on, computer, you can do it. There we go. Go to tests, and we go down to chi-squared goodness of fit, which is going to be down here a little bit. Come on, you can get there. There it is, chi-squared goodness of fit. And if you push enter, it says observed. This is the observed frequency, and then we have to put the expected frequency into list 2. So this here is going to be our x, and then our y, the list 2 is going to be what we would expect to happen. So let's go back into this and do that. So we're going to go into stat. We're going to edit. The list 1 is what we observe. So that's going to be the 8, 7, 6, 15, 12, and 12. Okay, and then this is what we are expecting to see if it is fair. And we know that since they kind of helped us out here because it says write down the expected frequency of rolling a 1. So we should expect to roll 10 ones, and guess what? They're all the same expected probability. So we should expect, if we roll the die 60 times, we should get 10 of each of these. So we're going to simply just do 10 for all of these, and then we're going to go back in and do our chi-squared. Oops, that number up there did not enter in correctly. Now we're going to go back in. Come on, there we go. 10. Sorry, I'm doing this on my old computer, and it makes it really slow. Now, fingers crossed, we should be able to go back into stat and go over to tests. And then now we're going to go down to the chi-squared goodness of fit test. And now it will give us our p-value. Okay. So there we are, chi-squared goodness of fit test. We push enter. And then the observed was in list 1. That's what we put in for X. And then the expected is list 2. That's all the 10s. Okay, so we simply can just push enter all the way down. Oh, wait, the degrees of freedom is not 3. Degrees of freedom is 5. I'm not sure why. It must have just defaulted to that. And then we want to push calculate. Okay, and so then we get our p-value of 2.87. 2.87 is our p-value. Okay. Let's see, find the p-value. So we did that on our calculator. And then part E here says state the conclusion of the test to give a reason for your answer. Okay, so this is another one of those things that, again, I believe we have to memorize. I don't think this is on the formula sheet. So what we do here is we write our p-value, and then we're all good if the p-value is greater than our significance level. So we get, oh, I wrote that down wrong. I put 2.87, but it's 0.287. My apologies. So that is 0.287. So I'll get rid of that. There we go. Back to part E. That's our pen here. So what we write is we've got 0.287 is indeed greater than 0.05, our significance level. Okay, so since this is true, we can either say that there's insufficient evidence to reject the null hypothesis, so we can only reject it if that's false, or we can write insufficient evidence to reject that the die is fair. We do have to write one of those two things down. This is not enough to give us all of our points. That would get us only one of these. Actually, it says out of 2. Yeah, this would only give us one of the 2 points. So what we want to do is say, since that's true, we would say there is insufficient evidence to reject the null hypothesis. Okay, and that would be our answer there. Okay. Now it's important that we write there is insufficient evidence to reject the null hypothesis. That's different than the null hypothesis is true. We just don't have enough evidence to say that it's not true. So that's two different things. Though it seemingly seems like it's saying the same thing, you definitely want to write that there's insufficient evidence to reject the null hypothesis. We haven't proven that it's true. We just don't have enough evidence to say that it's not true, which is, I know, again, weird, but that's okay. All right, let's take a look at number 8 here. Factory produces bags of sugar with labeled weight of 500 grams. The weights of the bags are normally distributed with a mean of 500 grams and a standard deviation of 3 grams. Part A, write down the percentage of bags that weigh more than 500 grams. Okay, since it says write down the percentage of bags, super important, and this here says write down the percentage. I just looked on the answer key. They are not going to accept a fraction or a decimal. They're only going to give you credit for this 1 point if you actually write a percentage. So this is an important piece on making sure you're reading the directions. Write down the percentage of bags that weigh more than 500 grams. So if the mean is 500 grams, not that you have to write this, but if we have our little normal curve here, sorry, that's not beautiful. Our mean right here is 500. So what percentage of the bags weigh more than 500? That's the top half. That's the bottom half. So this, for part A, is simply going to be 50%. Okay. Now, part B says, now it says a bag that weighs less than 495 grams is rejected by the factory for being underweight. Find the probability that a randomly chosen bag is rejected for being underweight. Now, if this happened to have, simply like this is minus 3 grams and plus 3 grams for each of our little standard deviations here. We could do it with, if you had memorized all these percentages, which most of you probably won't, and I wouldn't blame you, I wouldn't either. But this, since this is not an exact multiple of 3 off of the 500 grams, we'd have to plug it into our calculator anyway. So let's go ahead and do that. Okay, so we are going to plug this into our calculator, and this is the normal distribution, which is right here, distra. So we do second variables, which gives us all of our distributions. And if you'll remember, we always use only 2 or 3, normal CDF or inverse normal. The only time we use inverse normal is if they give us a percent, and we have to go off of a percent to try to find an actual value. On this one here, we are looking for the value. We did not get our percentages in here, so we're going to use normal CDF. So we go to normal CDF, we push enter, and now it's going to ask us to put in all of this information here. Okay, the lower, so we want a bag that weighs less than 495. So the lowest it could possibly be would be 0, right? And then the highest we want it to be is 495. So we put 495 in, push enter, and then this little mu here, that is our mean. If you look at it, it kind of looks like it could be an M. So that's how I remember that. And then little O with the little piece on here, I believe is, I can't remember what that one's called. Sorry, I call it super O. It's an O with a cape on it. That's always your standard deviation, so that's 3. Here's the good news. If you go through and put this in backwards, it should give you a really weird number that doesn't make any sense, so then you'd know you'd want to switch them around anyway. So we put those data in and we push paste, and it will actually paste it into this, and you're like, that doesn't tell me anything. You're right. You got to push enter one more time, and then it will give you your answer. So find the probability a randomly chosen bag is rejected for being underweight, 0.04779. I'm going to write 0.0478 to 3 significant figures, not to 3 decimal places, but to 3 significant figures. And it does actually accept a percentage as well in here, but I'm going to stick with the decimal point 0.0478. So B, we get 0.0478 is the probability the randomly chosen bag is rejected for being underweight. Okay, and then part C, it says a bag that weighs more than K grams is rejected by the factory for being overweight. The factory rejects 2% of the bags for being overweight. Find the value of K. All right, now when we're finding this value of K and they give us the percent, that's where we're going to use inverse normal. So we go back in here, go back into second variables, and that's our distribution. That's where we're going to use inverse normal. Because if you remember on the normal CDF, they gave us a high and a low. We don't have a high and a low. That's what we're looking for, so we can't put that data in. So again, if you forget, and you know it's one of these two, if you forget, if you try this one, you won't have the data to put in there. So you'll be like, that doesn't work. So then you know it's like, oh, I got to try the number 3 then. So it says bags that weigh more than K grams is rejected by the factory for being overweight. The factory rejects 2% of its bags for being overweight. So you don't have to do this, but I like to do this because it kind of helps me understand this a little bit better. I'm going to draw my normal curve, and it's the top 2% of bags is going to be overweight, right? So this is our rejection area here. So that if that's the top 2%, here's what we were doing in class for most of these, because not everyone's calculator has the left, center, and right part here. So there's a couple different ways you can do this. I'm just going to show you one way, and if you really don't like this way, you can ask me and I'll show you how to do it a different way. But anyway, it's the top 2%. So this is, we know that this here is 2%, so that means the rest of this over here is 98%. So what we're going to do in here is we're going to do the area. We're going to do 0.98, because we always like to start from the left and go up. 0.98. The mean is still 500. The standard deviation is 3. And on this one, the tail will always be, what for the way we do this. do this here, it's going to be 98%. I will at the end of this show you how to do it the other way as well if your calculator looks like this. But not everyone's calculator, not everyone has the 84 plus where it does this. Some of them don't have this part on here, so I want to show you that first. So we would go from the left and we'd push enter, and I think it'll go to paste. Okay, I guess I gotta fit the arrow down, push paste, and it's going to put it in there, and we got to push enter one more time, and that means that that number is going to be 506.0, or actually we would just round it to just 506, right? So part C is going to be 506. So any of the bags that are more than 506 grams, so this number right here is 506, are going to be rejected for being too heavy. Okay? Okay, now if that all made sense, call it good. You can skip to the next problem. I'm going to really quickly show you how to do it the other way as well. So we go back to inverse normal. And what we can do is we can actually go, this calculator will allow us to go from the right. So we will go back this, and that's just the 2%. So what we could change this area to 0.02. And then do the same mean, same standard deviation, and then our tail is going to be from the right, and we push paste, and we should get that, and we'll enter again, and we should get the exact same answer of 506. Okay, so you can do that either way. This is the way we did it in class because not all of our calculators were able to do left tail and right tail. It only would do left tail. Okay. That is it for that one. Let's go move on to number 9 here. It says the function f is defined by f of x equals 2 over x plus blah, 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 blah. Find f prime of x. That, hopefully you remember, is the derivative. Okay, now, the way we were doing this in class is we moved all of our x's to the top. We didn't memorize any extra formulas. We just knew that we moved everything, all the x's to the top, and then we took the derivative. So for part A, let me change it back to green here. So for part A, we've got f of x equals this 2 over x. If I move this x to the top, that's going to turn into x to the negative first on the top here. So it equals 2x to the negative first plus 3x squared minus 3. And now we're going to do the derivative. I'm going to back up for a quick second here, go back to number 8, because look, I put 506, find the value of k. I really should have put 506 grams. I should have labeled that, right? So probability is fine, doesn't need anything, that's percent, 506 grams. Sorry, back to number 9. So here's our simplified version where we moved everything up to the top. And now we are simply going to take the derivative of this thing, okay? We do negative 1 times 2, so f prime of x. Remember, all we did was move this top. We have not done the derivative yet. Now we're going to do the derivative. So negative 1 times 2 is negative 2x. Subtract 1 from that. Negative 1 and negative 1 is negative 2. And then 2 times 3 is 6x. Subtract 1 from that, and that's just to the first. And remember, all constants are, they turn into 0 when we take the derivative. And if you forget why, that's really negative 3 is the same thing as negative 3x to the 0. And then we go 0 times negative 3, and that turns this whole thing into 0. That's why that disappears. So there's our derivative for part A. 3 points for just taking the derivative, you guys. That's pretty good. Okay, and then second part says find the equation of the normal. Remember, normal means perpendicular to the curve at y equals f of x at 1, 2 in the form blah, 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 blah. That's the standard form, which is really not great for anything, where a, b, and d are integers. So we got to make sure you can't have these in fractions. And officially, we're not supposed to have a be negative as well. Okay, so we're going to find the equation of the normal to the curve at 1, 2 in this form. Okay, so if you remember, if we're finding the equation of the normal to the curve at f of x at 1, 2, remember the derivative will always give us the slope of the tangent line. Okay, so we want to find the normal, but first thing we have to do is find the slope of the tangent line. So then we're basically just going to take our x is 1, and we're going to plug 1 into our derivative, right? So f prime of 1, you don't have to include this part here. That's just showing that we're finding the value of 1. Okay, so we do negative 2 times 1 squared to the negative second plus 6 times 1. Okay, 1 to the negative second, 1 to any power is just going to give us 1. So that's going to simply just be negative 2 plus 6 times 1 is 6. So that's going to give us 4. Now that's the regular, that's just the plain old slope of the tangent. If we want to find the normal, we now have to flip it and switch it, right? So that's 4 over 1. So we got to flip that over to be 1 over 4. And since this was positive, this is now negative. Okay, so our normal, oh, I shouldn't circle that because that's not our final answer, but I'm going to underline it because we're going to use that. The slope is going to be negative 1/4, right? And then, let's see, we know that 1, 2 is going to be on our line. So that's going to be our x1 and our y1 when we plug it in our point slope formula here, right? So we're going to simply plug things in. And again, the nice part about this is all you have to do is plug it in. You do not have to simplify it. And I'd suggest not simplifying it because if you do a little simple math error in there, you're going to not get as many points. So we're going to do y minus, our y1 is 2. So y minus 2 equals, our slope is negative 1/4. And then we've got x minus 1. That right there is going to be the equation of the normal to the curve at 1, 2. Now, that's part of it, but it does say that we need to, so I should not circle that. It does say we have to put it in this form here. So with that, we actually do need to simplify this so we can move everything to one side. So we got y minus 2 equals, distribute this through to both parts here. Negative 1/4 times x is negative 1/4 x. And I emphasize distributing to both because this is the most missed part of simplifying this, is multiplying the negative by the negative, knowing that you're going to get a positive. A quarter, negative times a negative is positive. A quarter of 1 is 1/4, right? And then we're going to want to add 2 to both sides. And we get y equals negative 1/4 x plus 2 1/4. Okay, now I'm going to actually take that out. 2 times 4 is 8, plus 1 is 9. I'm going to actually turn that into 9/4 because that's going to make it easier for us when we simplify everything. Okay, now it says here that we got to put it in this form right here. So we got to make it equal 0. We got to move everything to the left side, and we got to have all integers. So we're going to add 1/4 x, and then that's plus 9/4, so we're going to subtract 9/4. So plus 1/4 x, and then minus 9/4. So everything's gone over here on this side, so we just get 0 equals, and we have 1/4 x minus 9/4. Oops, I should include and need to include, I forgot to include this y here, so 1/4 x plus y minus 9/4, because this tells us right here we got to have we got the x, the y, and then the constant. Okay, x, y, constant. We cannot have fractions, so we have to get rid of all those. So the easiest way to do this is multiply everything by 4. 4 times 1/4 is 1x. 4 times y is 4y. 4 times negative 9/4, these 4s are going to cancel each other out, and we get negative 9. 4 times 0 is still 0. There's our answer in this form right there. Okay? Okay, that's number 9. Moving on to number 10. Carl has 3 brown socks and 4 black socks in his drawer. He takes 2 socks at random from his drawer. Complete the tree diagram. So here's all of our probabilities. So if he's got 3 of the 7 socks are brown and 4 of the 7 socks are black, Now it's saying if you draw a brown on the first one, you have one less brown, so that 3 goes down to 2, and you also have one less sock from 7 down to 6 now, socks to choose from. So this is obviously showing us that there's no replacement when he's picking the 2 socks, okay? So if he picks a brown sock on the first one, there's still 4 black socks out of 6 total shown, right? So 4/7 chance that he picks a black sock. So if he picks a black sock, let's go down here. I'm going to do this one first here. So that means if he picks one of the 4 black socks, there's one left. Oops. Do this in green like we've been doing all the A's. So we do 3. There are 3 left out of 6 total. And that means that all these branches always have to add up to 1. So that means that there's going to be 3 brown socks because you didn't choose a brown sock out of the 6 total. So it should be 3, 6, and 3, 6 on those for completing the tree diagram. Okay, part B says find the probability that Carl takes 2 socks of the same color. So that's going to be this branch, or because that's brown and brown, or we're going to get black and black. So it's either going to be one of these two. So we would want to do, and I'd want to put this work in our answer box that's going to be underneath here, right? So I would want to do 3, this is part B, 3/7 times 2/6. Okay. And then also it's going to work if it is 4/7 times 3/6. Okay. So then we're just going to want to multiply this out. And then we do not have to simplify it. We can just multiply it out, add them together, and away we go. So 3 times 2 is 6. 7 times 6 is 42. Right? And then 4 times 3 is 12. 7 times 6 is 42. Makes it really nice because these denominators are already the same. 6 plus 12 is 18 out of 42. And it just says find the probability. So we can leave it as a fraction. So the probability of taking 2 socks of the same color is 18 out of 42. Okay? And then part C, given that Carl has 2 socks of the same color, find the probability that he has 2 brown socks. So we know, since he for sure has 2 socks of the same color, we know it's one of these 2 paths, because these are the only 2 paths we're going to get the same socks. So it says, given that, that means this 18 out of 42 is going to be our denominator. And then what's the probability that he gets 2 brown socks? That's this one here, 3/7 times 2/6. So 3/7 times 2/6 is 6/42, right? Now, if we have this here, 2 ways to look at this to simplify. If our denominators are the same, we can simply cancel them out. And the reason why is that this is the same thing as 6/42. If you're dividing by a fraction, you can flip this over and move it to the top to multiply. So we really turn that into 42/18. So these 42s go away, and we're just left with 6/18. You do not have to simplify. You can leave it as 6/18, or you could turn it into 1/3. But this is the route you want to go, just so you don't end up miscalculating when you simplify, because you do not have to simplify. Okay. So again, the shorter way to do this instead of doing that is doing the flip and multiply here. Is if the denominators are the same, we can simply cross those out, and you're left with 6/18. Okay. All right. That's all there is for this one. Let's move on to 11. Okay, strength of earthquakes is measured on the Richter magnitude scale, with values typically between 0 and 8, where 8's the most severe. Gutenberg-Richter equation gives the average number of earthquakes per year, n, number of earthquakes per year, which have a magnitude of at least m. For a particular region, the equation is this here. The region has an average of 100 earthquakes per year with magnitude of at least 3. Find the value of A. Okay, so we have our formula here. So for part A, we're going to write log base 10. And then it says n. N is the number let's see, number of earthquakes per year is n. So there's 100 earthquakes, so we're going to put 100 here, equals A, and that's what we're looking for, so we're going to leave that in here, minus M, and M is the magnitude of at least M, and this says magnitude of at least 3. So this M here is going to have to equal 3. And then what we're going to want to do is just simplify this here. Now, two ways you can do this. I'm going to highly suggest remembering that log base 10 over log, like the big number here over the little base number here, is always going to look like this: log 100 divided by log 10. It's just kind of nice this way. You don't have to worry about how to try to enter it into your calculator any kind of fancy way. You can just do that. So this is going to be A. That looks like a 9. So let's make it look like an A minus 3. So on our calculator, we are going to put in, I'm going to do this. So we've got log. It's going to be log 100. You know what? Let's make this even easier. Let's do alpha y equals, so we can do a fraction. Otherwise, you have to put it in parentheses to make sure that you get it right. But if you do it this way, you'll always get it right. Log 100. And then on the bottom, we're going to do log 10. And we're going to push enter, and we're going to get 2. Because what this means is 10 to what power will give us 100, and that's 10 squared. So this over here simply is 2 equals A minus 3, so we add 3 to both sides. So that means our A has to equal 5. Okay? So that's A. Part B says the equation for this region can also be written as n equals B over 10 to the m. Find the value of B. Okay, so, oops. Change our color, make it easier to understand. Part B, find the value of B. So we got n equals B over 10 to the m. So the number of earthquakes is 100, so we'll do 100 equals B over 10 to the m. The magnitude is 3. So this will simplify to 100 equals B over 10 to the third is a 1 with 3 zeros after it, so it's 1,000. Multiply both sides by 1,000, and we get that B equals a 1 with 1, 2, 3, 4, 5 zeros after it. 100,000 is what B is going to have to equal. Okay. Part C says, given that M has to be between 0 and 8, find the range for n. Okay, so this n has to be between 0 and 8. All right, here for C, given 0 to 8, find the range for n. So we now know that B has to be 100,000. So our new formula now is going to be n equals, instead of B, it's 100,000 over 10 to the m, and the m can be as small as 0, or we also have n equals 100,000 over 10. Where's 8 coming from? I don't know. 10 to the 8th power. Okay, so we simply want to just simplify both of these, and away we go. So now these are both in powers. These are both in like the normal numbers. So let's change both of these to, that's going to be 10 to the, just count the zeros, 1, 2, 3, 4, 5. So this is going to be n equals 10 to the 5th over 10 to the 0. And this is going to be n equals 10 to the 5th over 10 to the 8th. So if we simplify that, remember we move this to the top and it turns to negative, or you just do 5 minus 0 here. So we get n equals 10 to the 5th, and then this is going to be 5 minus 8, so that's going to be n equals 10 to the negative 3rd. So this being the smaller number, we would want to write this as 10 to the negative 3rd is the small one, and then 10 all the way up to 10 to the 5th. We want to do less than signs here, and then our n is what's going to be in the middle here. So n is going to be greater than 10 to the 3rd because there's no equal to signs on these. I shouldn't put them on there. So there's no equal to signs on those. So there won't be any over here as well because it's saying m has to be greater than 0. So n is going to have to be greater than 10 to the negative third and less than 10 to the fifth. So that's what our part C here, that's what our range for n would have to be. Okay? Last part, D, the expected time length in years between earthquakes with a magnitude of at least m is 1 over n. Within this region, the most severe earthquake recorded has a magnitude of 7.2. Okay, oops, let's change our color here. So that's going to be 7.2. Find the expected length of time between this earthquake and the next earthquake of at least this magnitude. Give your answer to the nearest year. Okay, so this is going to be part D. Let's see if we can squeeze this all in up here. So it says that our m is 1 over n. So n is b over 10 to the m. So 1 over n would just be this, since this is n over 1. If we flip this over, we would then flip this over. So that means 1 over n is going to be the same thing as, we flip this over, so it's going to be 10 to the m over b. Okay, so I really should be doing this down here, sorry. So we got 1 over n has to equal 10 to the m over b. We know that b is 100,000, so we've got, let's see, this 1 over n is the same thing as m, so our magnitude is, let me back this up for a second. Okay, I'm just going to get rid of that m because this is just going to be the time that it takes, right? So it's going to be 10 to the m, and then the m in this case here is, the magnitude is 7.2, so 10 to the 7.2 over b, which is 100,000, which if you'll remember we turned 100,000 into 10 to the fifth. So let's do that, 10 to the fifth. So this is going to be how long it's going to take between earthquakes. So if we get our calculator, I'm going to alpha y equals so that I can get a nice little fraction here. And we're going to simply do 10 to the 7.2 on the top, and on the bottom we're going to do 10 to the fifth on the bottom. And push enter, and we get 158.48. So we get to rounded to 3 significant figures. We're going to get 158, and this is in, everything here is in years, so 158 years. Should expect 158 years before we get another one that's magnitude 7.2. Okay? Okay. Moving on to number 12. Company's profit per year was found to be changing at a rate of d over p to d over t equals 3t squared minus 8t, right? That's our derivative. Where p is the company's profit in thousands of dollars and t is the time since the company was founded measured in years. So change in profit over change in time is going to equal this. Determine whether the profit is increasing or decreasing when t equals 2. Okay, so really all we're going to want to do is simply just plug in 2 for t and see what happens here. So part A we're going to do, so we got d, change in p over change in time is going to equal 3 times 2 squared minus 8 times 2. So that's going to give us 2 squared is 4 times 3 is 12 minus 8 times 2 is 16. We get negative 4. Okay, so since d of p over d of t is negative 4, that means, therefore, it is decreasing. So therefore, p is, our profit is decreasing because that's a change in profit over change in time. So profit is decreasing. Okay, so profit is decreasing when time equals 2. 1 year after the company was founded, the profit was $4,000. Find an expression for P of T when T has to be greater than or equal to 0 because time can't be negative. So find an expression for P of T. Okay, what we have to do for this is anti-derivatives, which is something else that we did not get to in our class, but I will show you how that works anyway. So we're used to doing derivatives. So derivative, you take the power, multiply by the number in front here, and subtract 1 from that. So antiderivative is doing the exact opposite. So what we're going to want to do here, we'll put b down here. So we've got 3t squared minus 8t. So what we're going to do is we're going to actually add 1 instead of subtract 1. We're going to add 1 to this here. So plus 1 is going to be 3. And then we take that 3 and we divide by 3. So we're really doing the exact opposite thing. Okay, so 3 divided by 3 is 1. So we have t cubed. And then this is t to the first. We're going to add 1 to that. That's going to be t to the second. And we're going to take that 2, that power of 2 here, and we're going to divide it out front here. So we get negative 8 over 2 is negative 4t squared. Now, there's going to be some kind of constant out here that we're going to need to figure out with that. So this over here is going to simply be our profit, right? And in this case here, our profit is going to be our y, and our t is going to be our x. Okay? So we know that 1 year after the company was founded, so that means that t has to equal 1. The profit was $4,000. So the 4 is going to have to be our p, which in this case is our y. So we're going to do 4 equals, time is 1. So we'll do 1 cubed minus 4 times 1 squared plus c. And we should be able to now figure out what our c is from that. So 4 equals 1 cubed is 1. 1 squared is 1 times negative 4 is minus 4 plus c. So we get 4 equals negative 3 plus c. Add 3 to both sides. C equals 7. So it says find an expression for p of t when t is greater than or equal to 0. So now we're simply just going to take that 7 and plug it back in up here for this c. So our overall, our ending piece here is profit is going to equal t cubed minus 4t squared plus 7. This is our equation. Okay? Officially up here it says p of t, so just to make this look a little better, let's put p of t equals t cubed minus 4t squared plus 7. Okay? So that is antiderivatives. Again, we did not get to that part here, but that's, we have enough info to do that 2-pointer, but we did not have enough info to do the 4. So if that happens to show up and you remember that, perfect, you got it. Last one on paper 1 here. Balls drop from a height of 1.8 meters and bounces on the ground. Maximum height reached by the ball after each bounce is 85% of the previous maximum height. So show that the maximum height reached by the ball after it has bounced for the 6th time is 68 to the nearest centimeter. So we can't use 68 to go in and plug it in. We have to show that we're going to end up after 6 bounces. Oops, wrong color again. After 6 bounces, we got to show that we're going to end up getting 68. Okay, so what we're going to probably want to do here is, when we're noticing that it's going down by the same amount each time, it's 85%. So this is a geometric sequence, right? Okay. Okay, so geometric sequence, but we can make our life a little bit easier. We can just do, let's do this. So the height is going to be, we always start with our original height, which is 1.8 meters. So we got 1.8 meters. And then we're going to multiply it by our growth rate. In this case, it's 0.85. So 0.85. And it's going to be to the after the 6th time, it should equal 68 centimeters so we'll put to the 6th here. Okay? So we're just simply going to want to put that into our calculator, and we're going to do 1.8 times 0.85 to the 6th power, and we get 0.679. 0.679, but this is in meters, and it says 68 centimeters to the nearest centimeter. So if you don't remember, our little metric system here is, to remember how to translate everything here, is King Henry died unexpectedly drinking chocolate milk, and U is for units, right? So to go from units over to centimeters, we got to move the decimal over twice. So we go 1, 2. So this officially would be 67.9 centimeters, but it says to the nearest centimeter, so the height would be 68 centimeters. Now this whole process right here is showing, that's it says show, so we have to start with our formula and show that we end up getting to 68. So this whole process is what they're going to be looking for, okay? Now we can also use this, u to the n equals u to the 1 to r to the n minus 1. Only reason why I don't like using this is because this makes it a little bit confusing over here. So I'll just show you how this one works. So our u sub n would be our height in this case, and then u sub 1 is the first height. Okay, so that's the starting height, which is 1.8. And then r is the common ratio, which is 0.85. Okay, and then we've got n minus 1. Now the problem is this is officially 1. So then after this would be 2, which is only the first bounce, right? So then it's saying for the 6th, after it's bounced for the 6th time, so we actually have to add 1 to that 6 to make it 7. So this would be 7 minus 1, which is really 6. And if you'll notice, that's just the 6. That's the exact same thing as this here. Okay, so you can look at it that way as well. I kind of like looking at it this way better because I don't have to worry about this being 1, 2, 3. I could be 0, 1, 2. Anyway. Part B, find the number of times after the first bounce that the maximum height reached is greater than 10 centimeters. Okay, so what we want to do here on B then is the maximum height reached is greater than 10 centimeters. So 10 centimeters is the same thing as there's centimeters back to units. So we got to move the decimal over twice. So that's 0.1 meters. Since all of this is in meters, let's keep it with that. So we do 0.1 meters, and we want to know when the height reached is greater than that. So this is going to have to be greater than, and then so then we're going to do our 1.8, and then we've got 0.85 to the n. Okay, so you can actually do this a couple different ways. You can literally put this into one of you, like you can do on the graphing calculator, you can solve this graphically by putting this in for one of the equations and this in for the other equation, or we can do good old logarithms. So I'm going to show you logarithms, and then we can go back and show the graphing calculator way too. So we're going to divide both sides by 1.8, and we are going to get, let's see, I did this already here. Let's get rid of it. We'll do it over fresh again. 0.1 divided by 1.8 gives us 0.0555 repeating, and we get 0.85 to the n. So to get rid of the n from the exponent, that's where we have to do log. So we do log 0.0555 is less than n log 0.85. So we divide, to get n by itself, we divide both sides by log 0.85. Log 0.85. And that's going to tell us that n has to be greater than, and whatever we get for that. So we will do log of our answer equals, and then divide by log of 0.85. And we get, oh, what did I do? Let's try this again. 0.1 divided by 1.8 is our 0.555. So we're going to do log of that answer equals, and then we're going to divide by log of 0.85, which, there we go, 17.78. So 17.78. N has got to be greater than 17.78. You can't have 0.78 of a bounce. We want to know the exact bounce, so that means that N would have to be greater than 18. But here's the weird part. It says find the number of times after the first bounce. So it's already bounced once. So it's going to bounce 18 total times. So if it's already bounced once, we'd have to do 18 minus 1 to get 17. So it's going to have to bounce 17 times after the first bounce. Why did they give us after the first bounce? I don't know, but we will play their game. All right, C. Find the total vertical distance traveled by the ball from the point at which it is dropped until the fourth bounce. Okay, so now that's where we're going to want to use our sum formula, sum of a geometric sequence. Okay, so here's what your formula book gives you. And it gives you two formulas. They're really the exact same thing. They just have written it a little bit backwards. So I would just suggest just getting rid of one of these and just know that R cannot equal 1 because you can't have 1 minus 1 equals 0 divided by 0. So this is our sum formula that we want to plug it into. So S of N equals U sub 1, the first term, 1.8. All times our rate, which is 0.85 to the fourth, right? Because it says the vertical, which is dropped until the fourth bounce. So this is 0. There's, let's see, I guess to the first bounce. So there's 1, 2, 3, 4. So we're getting all the way out to there, okay? Fourth minus 1. And then that whole thing is all over our rate, 0.85 minus 1. Okay, so let's just stick that in our calculator and see what we get. Okay, I'm going to clear that out. Alpha y equals, so we can get the whole fraction thing. Just push enter and it will give us the basic fraction. So 1.8 parentheses 0.85 to the fourth. Go over there, minus 1, and then we shouldn't have to close off the parentheses, and then we're just going to do 0.85 minus 1 on the bottom, and push enter, and we get 5.735. Now, here's the weird part. This is just counting this distance here. It's not counting the distances back up. So really what we just calculated was this, 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 and this. Okay, so really what we want to do with this here, so this 5.735 again is all the blue, so we also have to add this, this, and this back in. So I'm thinking the easiest way to do that is to simply double this. So we're going to take that and multiply it by 2. And that gives us 11.47185. I'm going to leave that whole thing on there. So we've got 11.4, I already forgot the rest, 47185. Okay, but this now includes this, 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 and this. But we actually don't want this part in here. But we know that that's 1.8 meters from here down to there. So we would take this 11.47185 and subtract 1.8 from that. So we take our calculator, subtract 1.8, and we end up getting 9.67 if we round it to 3 significant figures. So 9.67, and this is going to be meters, would be that total distance the ball has traveled. Okay, that one, that's that's a little bit of a tricky one there to really go through and figure all out. I feel like really the rest of this whole test did not have too many tricky things. There's a couple things we didn't cover, but for the most part, you should really be in pretty good shape if our test ends up looking like this. But anyway, that's all of our answers here for all of these here. If you have any further questions on any of these, please, by all means, ask in class, and I'll be happy to help you out. Okay? Thanks.